Well, hello again. Mr. Bucko here with my favorite problem from the Geometry Chapter 8 self-test, number 13, where we have a figure below where the angle n, the measure of angle n is 60 degrees, the measure of angle m is 30 degrees, PS is parallel to NM, the distance from S to M is 12, and the distance from P to S is 8 times the square root of 3, and we have to find the area of PSMN. And notice how they don't tell us what this figure is, but from all of this information we can conclude that it is a trapezoid because we know that PS is parallel to NM, and a trapezoid has at least one pair of parallel sides. And the area, since we need to find the area of a trapezoid is base 1 plus base 2 times the height divided by 2, or times 1/2. So let's first put in this information we have. We have that angle n is 60 degrees. They tell us that. That was already there. They tell us that angle m is 30 degrees. They tell us that right there. And then they tell us that SM is 12, so this distance is 12. And they also tell us that PS is 8 times the square root of 3. That's right there. So PS is base 1 or base 2, whichever one you want to call it. We need the base n to m. And we're also going to need the height here, the distance between the parallel lines. So we don't have any of that information, and we have to find that information with the information that we have. So I need, or we need, these lengths here. And notice I put them there right at the edge so that I'm forming two triangles here. And these black lines indicate the height of the trapezoid, which we need to find the area of the trapezoid. So I'm going to do these one at a time, and really one at a time meaning I'm going to look at just one of the sides, not both of them at the same time, because once I have the length of this, I know the length of that. So I'm going to start with this triangle over here. And this triangle right over here is a 30, 60, 90 triangle, and I know that because this is a right angle. It has to be, otherwise this is not the height. This is a 30-degree angle because we're told it's a 30-degree angle. And therefore, this angle has to be a 60-degree angle because of the fact that there are 180 degrees in a triangle. So, based on that, I can conclude that the height is 6. Where does this 6 come from? Well, again, this is a 30, 60, 90 triangle right here. And the hypotenuse, which is this side, because it's opposite the right angle, the hypotenuse of a 30, 60, 90 triangle is 2 times x. It's the relationship of all the sides, where this hypotenuse is 2x, the side opposite the 30-degree angle is x, and then the longer side, the longer leg, is x times the square root of 3. So the hypotenuse is 2x. Well, 2x is 12. Well, if 2x is 12, then x has to be 6, and the shorter leg has got to be 6, which is therefore this side, which is the height of the triangle. So therefore we know the other height right here is also 6 because that's the height of the triangle also. So we have the height now of the trapezoid from the 30, 60, 90 triangle relationship that we see right here. Now we need the base, the NM, distance from M to N. What is that? So we have some information we can kind of plug in here. First, I know that this length is 6 times the square root of 3. Again, that's going back to this triangle right here. This triangle right here is a 30, 60, 90 triangle. This is 12, and 12 is equal to 2x. Therefore, x has to be 6, which is the short leg. And the longer leg is x times the square root of 3, which is where I get this 6 times the square root of 3. So the 6 times the square root of 3 represents the distance from here to here. That's not quite the base, but it's a part of the base. And now what we can do is go over to this also 30, 60, 90 triangle and find out this length here. Because this is a 30, 60, 90 triangle. Again, I know that because this angle right here is 90 degrees because it's from the height. This is 60 degrees because we're told it is. Therefore, this has to be 30 degrees because that's what's left over. So in this case now, this 6 is the x times the square root of 3 side. I have this 8 times the square root of 3. Where did that come from? So sidebar here. That comes from this distance, which is equal to that distance. Now we can go back to this right here. And now I know that 6 is equal to x times the square root of 3, because looking at this triangle, this leg right here, this is the long leg, because it's opposite the 60 degrees, is x times the square root of 3. So solving for x, I have to divide both sides by the square root of 3, but I can't have a square root in the denominator of a fraction. So then I'm going to multiply 6 over the square root of 3 by the square root of 3 over the square root of 3, leaving us with 2 times the square root of 3. Might not be a very good explanation because I said that and didn't write that down. But this side is x times the square root of 3. So solving for this x, I divide both sides by the square root of 3. I get 6 over the square root of 3. And then I can multiply the numerator and the denominator by the square root of 3 to eliminate this radical in the denominator. And then you essentially get 6 times the square root of 3 over 3. And 6 divided by 3 is 2. So that's kind of where that 2 comes from there. It's a little bit of algebra that is verbalized but not written down. And this 2 times the square root of 3 is this length here. 8 times the square root of 3 is this length here. And again, where does that come from? It's because this same exact length right above it is also 8 times the square root of 3. So therefore this is as well. And then we have 6 times the square root of 3. So the entire base now, we have all these roots of 3. 2, 8, and 6 roots of 3 make up to be 16 roots of 3. So there's that same picture right there. And this whole length is going to be 16 roots of 3. 2 plus 8 plus 6 roots of 3. Now we have base 1, we have base 2, and we have the height. Here it is plugged into the area of a trapezoid formula. Base 1 plus base 2 times the height times a half. What's that look like? There it is again. Simplifies to this. The 24 roots of 3 come from 16 roots of 3 plus 8 roots of 3. That's where this comes from. 16 plus 8 is 24. The 3 comes from 6 times a half. And then 24 roots of 3 times 3 is going to be 72 roots of 3. Square root of 3 is an irrational number. I'm not going to evaluate that. I'm just going to leave it as a square root of 3. So our answer is 72 roots of 3. What a great problem.